Hey Maggie, this is just for you. Hope you watched and tune in. We're looking at the review worksheet and doing the ones that I thought were helpful first, and then I'll take questions from the audience. Number 15. The number of elephants in a preserve is given by a differential function e of t. Selected values of e of t are given on the table to the right. Approximate e prime of 5. Indicate units of measure.
Okay.
E prime of 5. The derivative of e. dE dt. Well, I don't have an equation to take a derivative of, but that's why it says approximate. Well, I think dE dt I could approximate with change in e over change in time. This is a little bit like MVT. It's not MVT because we didn't meet the conditions, we don't know, but calculus slope approximately equals algebra slope. So let's do the algebra slope as best we can at 5. Well, there's not a 5 over there, but if I want to know about how much it was changing when time equals 5, I should probably use 3 and 7. So, change in elephants would be 34 minus 26. Change in years would be 7 minus 3. And safe stopping, you could stop right there. But this would be a multiple choice test, so 8 over 4 is 2. Indicate units of measure, though.
Elephants?
Well, we did
year?
Elephants per year. Elephants divided by year. I can spell elephants.
Elephants is a weird word.
Elephants per year. So that means the dE dt, the approximate slope of the elephant population, is it's growing by 2 elephants per year. Approximately. We don't know exactly what's happening in year 5.
There could also be like protein.
But from 3 to 7, it changed by 2 per year. That we can say for sure. From 3 to 7, it changed by 2 per year. Exactly what happened in year 4, 5, and 6, we don't know. But that's okay. Approximate. Explain why there must be a time t in the interval 0 to 9 such that e prime of t equals 2. Why there must be a time in the interval. That sounds like MVT language.
Well, it's differentiable and therefore continuous.
So e is, I'm going to say exactly what you said, differentiable, because they told me it was differentiable, and therefore continuous. So that means the I rock equals A rock somewhere on the interval. But we just found the A rock to be 2. A rock equals 2 on 3 to 7. So that means e prime of t equals 2 somewhere on 3 to 7. Because MVT. AP likes to do this kind of thing. They ask you a question, like, okay, get an answer, and then you don't know it at the time, but they sort of secretly have led you into part of the next question because you worked part of the next question already. Numbers 19 through 20, through the rest of the page, really. Or I guess 18 through 26, the ones that go with the graph. This is a very popular question on the AP test. I mean, almost guaranteed, they're going to, at some point, give you a graph of G prime, and they can ask you a million questions about it.
And I have the answers as if it were G.
And hopefully, yes, exactly. And the wrong answers will be, if you misinterpret this as the graph of G, I bet you one of these answers will be there. Which of the following is false? Okay, G has a relative maximum at x equals 4. Well, at x equals 4...
Changes from...
Wait, what changes?
The slope of G prime.
Not the slope of G prime, just G prime. Changes positive to negative. So that's a relative max, so that is true. Or a relative max of G. G has a relative min at x equals 7. Let's see, at x equals 7, G is changing. No, G prime is changing. Negative to positive, that's a relative minimum. Negative to positive, yeah, that's a relative minimum. So B is true. G is a constant on 0 to 2. G is a constant on 0 to 2. What's G prime on 0 to 2?
0.
Nope. What's G prime on 0 to 2?
2.
2. So what does that tell me that G is doing on 0 to 2? Increasing. In fact, it has a slope of 2. That's just a line with the slope of 2 from 0 to 2. So C is not right. G prime is constant on 0 to 2, but G is increasing because G prime is positive. Let's verify this with looking at D. G is increasing from 0 to 4. 0 to 4. G prime is positive the whole way there. So G is increasing. So that one's true. So C is false, but man, it's really easy to see that flat line and think, oh, flat line's constant. Well, yes, but this flat piece is G prime, and they didn't ask about G prime, they asked about G. Try 19, 20, and 21. They kind of go together. 19, 20, and 21. Presume. Brandon, what do we think? On what interval is G decreasing?
4 to 7.
I like that answer. Why did you say that?
G prime is negative.
Good. That is a great answer. That's a perfect answer. Sometimes students see that justify your answer and they think, aha, I will explain all that I know about the first derivative and justify my answer. Like, no, just give me the reason. I don't need, in fact, sometimes the more you write, I think the less you know, right? You're trying to throw everything you know on the page, hoping that something is correct.
You're just throwing crap and hoping something sticks.
Yep. And it would just be a whole lot better if you knew the answer and just said G prime is negative, because that's what you looked for. Bell, at what value of x does G of x have a relative minimum?
X equals 7.
And why did you say that?
Because G prime changes from negative.
Perfect. Again, justify or explain doesn't mean a paragraph. It means give a good, solid calculus reason, and it might be a short phrase. It might be a longer phrase if it's like MVT or something crazy. But it never needs paragraph explanation when we need justifying. Austin, I think yours is maybe the trickiest because we haven't talked about this in a while, but at what values of x is the second derivative, which is the derivative of G prime, that's a pretty good hint, undefined? Don't know. Okay, so let's focus on the derivative of G prime, because I've got the picture of G prime, and the derivative is kind of the same thing as slope. So are there places on the graph where the slope of this graph is not defined? And what are those places? I think there's 2 of them.
4 and 7.
Not 4 and 7. At 4 and 7, G prime is equal to 0. So I want to know where the slope of this actual graph isn't defined. Somebody help him out. Where is it not defined?
6. X equals 6.
2 and 6.
2 and 6. And why is there not a derivative there? Why is there not a slope there? Cusp. Explain how you got your answer. Cusp.
Quick turn.
Quick turn, sharp turn. Don't need a long explanation on that one. There's a cusp. Right. Oh, these are all related, so we'll do and we can do all of them. What is the second derivative of g at 1?
0.
That was quick. What were you looking at? How'd you know that?
The slope of y.
Yeah, because that's the slope of g prime. And in fact, as long as you know that g double prime is the slope of g prime, then you can answer all 3 of those. Discuss the concavity of g. Justify your answers. Well, if g prime is increasing, that means g double prime is positive, which means g is concave up. So I just justified my answer without even looking at the graph. But now I know what to look for. G prime is increasing from 6 to 8. If g prime is decreasing, that means g double prime is negative. That means g is concave down. So on my graph, that's from 2 to 6.
Yes.
And it has a point of inflection. If we just answered 25, 26 is easy. There's a point of inflection where it changes at x equals 6.
So are these the kind of concept questions that you're doing in the test for?
This is one that could be a free response. Because on those free response ones, we like to get you on the justify, explain kind of stuff.
You tell me.
Number 17, I just want to, so I was looking on the sheet and I found the value.
Okay.
It says that the f(x) is a reported polynomial, and that means that the relative minimum is equivalent to the absolute minimum. But how we that tonight? Is that something?
Yeah, we didn't really. No, we didn't.
I found the minimum, but I didn't know that it would plug in. Okay. I just didn't know if I.
So the only thing that would be a problem is -3, because 0 is a double root, so it's not going to change there.
Yeah. So then just be plugging -3 into the original equation and solving.
Right. Yep.
Okay.
The point of inflection is where the concavity is.
Correct.
It's like 60 degrees.